So we are going to go ahead and get started. Just two of you here at the beginning of today's session. So we'll kind of go at your speed. Let me know if you want to go faster, slower, and we'll go from there. So we're doing two sections, right? You took exam one, did pretty well. I was very happy with the results of those. Those are all graded. So if you haven't looked at your overall grade after they've been adjusted for what I had to grade, those are done as of this afternoon. So check those out later. Let me know if you have any questions about anything. Just shoot me an email of which one you had a question. I'd go ahead and look at it and get back to you. So we begin Unit 2 today, Sections 10 and 11. And so looking forward to this week, we've got two web work sections. You have, I don't know if I even should call it an Excel assignment. The dosage calculations, you can use Excel, but you don't have to. And we're going to do a problem by hand today, I believe, that I'll point out, hey, this is like your dosage calculations homework. I like that one. I think, especially if you're going into the medical field, it really kind of shows you how conversions can be good and bad in the field. You've got a quiz and you've got the discussion board. So just also to recall, project one is due next week on the 6th. So some people have already turned it in, and that's great. If you haven't, you have a week, a little over a week, I guess. And remember, I will check your Excel portion. So if you have questions on that before you turn it in, just go ahead and shoot me that before we go from there. We do need to talk about next week. I will not be around on Wednesday. So we're going to do maybe some optional sessions, different days, different times, and we will talk about that. Whoever's here at the end. So if it's just you two, you guys will kind of get to determine when we have an optional session, something that works in your schedule besides Wednesday afternoons. And we'll talk about that at the end. So do either of you have any questions before we kind of jump into the new material? Going once, going twice. Lil says no. Matt's good. All right, so let's go ahead and get started. So you are going to need your packet for today, most specifically page 245, which is yellow. That yellow sheet is actually the conversion or the formula sheet that you will be provided with for the next two exams. So when you go in to take exam 2 and exam 3, not only will the testing center people put the password in, but they will also give you this formula sheet. So just something to keep in mind that is coming. Okay, so this allows you to, you know exactly what you're going to be given on the exam because you have a copy of it there with you. So let's go ahead and jump in to Section 10, Conversions with the US Customary Unit. So the first thing we need to discuss is identity ratios. We are going to be using items called the factor label method. Almost lost it there. But the factor label method allows us to do these conversions. And if you don't know what they mean or how to use them, that's where the issue is. Okay, so have either of you heard of an identity ratio or have any idea what I'm talking about when I say that? No idea. Okay, great. Well, if you think identify ratios, no, that should be a D. Identity. It's a T. Identity ratios. Man, I can't spell. Anyway, an identity ratio basically is a ratio, which is a fraction, where the numerator and the denominator mean the same thing. So an example would be 7 days over 1 week. This is an identity ratio. The top and the bottom are the same, but the labels are different. So super crucial here in the first 3 sections of this unit, labeling. Now we can also write that identity ratio as 1 week over 7 days. Every identity ratio can be written two ways because the labels can be flipped. So 12 inches over 1 foot. That's an identity ratio. That can also be written, as you might see, 1 foot is 12 inches. So we're going to be using the factor label method here in a moment that works through some of these problems, and it does so using identity ratios. So we're going to have to use the concept of fractions, multiplying fractions, and reducing fractions as we work our way through these problems. Now, it's not as bad as it sounds. I mean, when I say fractions, some people start to hyperventilate. It's not that bad. So, but that's the idea. When I say identity ratio, I'm looking for a fraction where the numerator and denominator equal the same thing, but they're using different units. And if you look at page 245, at the there, I should have that page out. You see, sorry about that. at the very, very top of page 245, you see the US Customary units. And so you have a lot of different identity ratios given. They're given with an equal sign, but we can just throw that into a fraction and we have ourselves an identity ratio. So let's get in to see how we're going to use this. And we're going to start with what I call easy problems. When I call conversions easy problems, that means they're simply one step. Anything more than one step is no longer easy because it gets a little bit complicated. So my pedometer said I walked 11,520 feet yesterday. How many miles is this? Now, when you're doing straight conversion problems, you always will start with what you're given. So in this particular problem, I'm given 11,520 feet, and you want to make sure that you have your label. Now, I've talked earlier that we're going to deal with fractions. So how can I make 11,520 into a fraction? We can make anything a fraction by putting it over 1, right? Anything can be a fraction if you put it over 1. So because we're dealing with fractions, we want to start with a fraction. And then I like to say, let the labels guide you. So when I'm looking at this next piece, my final answer wants to be in miles, not feet. So when I'm looking at this, I want to say, okay, how do I make feet disappear? Well, if I think about reducing fractions, right now I'm in the numerator, so I want to put feet in the denominator because mathematically I can then reduce them numerator to denominator. So when I look at my sheet, I can see that feet go to miles. And I like to start with my labels because if I can get my labels in the right spot, then the numbers just come along. So I know from the US Customary spot at the top of my paper that 1 mile is the same as 5,280 feet. So that blue fraction right there is my identity ratio. So the point of this is that feet will cancel out with feet, numerator to denominator, and now miles is where I want to be, so if my label matches, I'm good to go. Now if you think about this, we can do it 2 ways. One way is you can multiply straight across and get 11,520, and multiply straight across on the bottom and get 5,280, and then divide. That's one way to do it. Another way is to think about anything in the top is multiplication, anything in the bottom is division. So if I start with 11,520, 5280 is in the denominator, so I'm just going to straight up divide by 5280. Either way, how many miles is that 11,520 feet? .18. Thank you. And then remember, that is miles. So you want to make sure that you label, you get in the habit of labeling. WebWork may have a spot already labeled for you, but you want to kind of get in the habit when you're doing it by hand that you label your answer. Right? So this is the idea of the factor label method, is that we're going to use identity ratios with the labels within the fractions in order to move through our problem and go from there. All right, stop me if you have questions, but I'm going to kind of just keep motoring because I think I have 31 slides and we're on slide number 6. So there's quite a few examples in this one here today. All right, number 2. This is not an easy problem, meaning it's more than one step. So I bought a gallon jug of juice, right? A gallon. How many cups is this? So I start with, I have a gallon of juice. 1 gallon. I make it a fraction by putting it over 1. Now, I don't want to be in gallons. I want to get rid of gallons. So before I even look at my sheet, I'm just thinking, okay, if I want to get rid of gallons, numerator, then gallons has to go in the denominator. And when I look at my yellow sheet, gallons only goes to one thing. Gallons goes to quarts. So my only piece here is to go from gallons to quarts. Well, our identity ratio, 1 gallon, is 4 quarts. So that process right there makes my gallons disappear, and my label is now quarts. But I want cups. That means I am not finished. So now I have to work on, how do I get rid of quarts? Well, if quarts is in the top, to get rid of it, I'm going to put them in the bottom. So if I look at my sheet, quarts goes to pints. right? Again, I'm always starting with my labels. So then I go 2 pints is 1 quart. Okay, well, that step makes my quarts disappear. Now I'm in pints, but again, I don't want to be in pints, I want to be in cups. So I go to my next one. Pints will go on the bottom, right? Top to bottom to reduce. Pints goes to cups. So 2 cups is 1 pint. That allows my pints to go away. Now I'm in cups, which is where I want, and I'm ready to do my math. If you notice, all of my non-zero numbers are in the top. So 1 times 4 times 2 times 2, and my answer is simply 16 cups. If you let your label lead you to the next step, it's a whole lot easier than if you just try to use all numbers, because it can get very confusing of what number goes where. And that's why I always put your label first, fill in the number later. Okay. All right, I want you guys to try this next one. I bought a 17.3 pound turkey. How many ounces is this? I would call this an easy problem because it's just one step. So go ahead and try to work this one out. Feel free to just throw your answer in the chat box when you got it. Or if you have questions, let me know that too. All right, so Lillian's got her answer. Not sure if Matt agrees or disagrees, but we'll go with it. Right, so that is correct. You did forget your label, but I won't be mad at you for that. So 17.3 pounds over 1. And then we know that there are 16 ounces in 1 pound. That process makes your pounds go away. We multiply straight across, and 276.80 Z's. Yeah. And there's your basic piece, right? So that's pretty basic one step, but if you don't understand the 1 steps, you're not going to be able to get the other ones. So, all right, so basic, that's US Customary. That's the very first part of section 10. Stop me if you have questions. But now we're going to go to metric. So you can use the factor label method with metrics. I dislike it. I think it's a lot of work and it can be very confusing because the metric system is based off powers of 10. So if you think back to scientific notation, which is powers of 10, that's basically what we're doing here. So you can count. If you can count to 6, you can be pretty successful with metric. Now, in the middle here, this first one is just to diagram. The middle one is the unit. So like liters, if we're talking about liquid, grams deals with weight, and meters deals with length. So, you know, millimeters, milliliters, milligrams. So the front letter is the prefix, the last letter is the unit. So that's why we have centimeter, centigram, centiliter. The little letter on the outside deals with the prefix. Okay, so I want to show you how we're going to count, and then I'll let you count a little bit. So there's just a nice little process, and I kind of like it. So we're going to change 360 centimeters to hectometers. Now, I always start with where am I starting? I'm starting in centimeters. That's here. So X marks the spot where I start. I want to go to hectometers, and hectometers is over here. So my goal is to go from X to O. Now, looking at this, directionally, I am going to move. Ooh, I picked the wrong color. Excuse me here. We are going to, from centimeters to hectometers, I need to go left, and I'm starting on the X. 1, 2, 3, 4. I need to go left 4 units, and that's a decimal point that I'm moving. So if I have the number 380 and the decimal point's at the end, well, I just need to move that decimal 4 places to the left. So 1, 2, 3, 4. 0 gives in my empty hump. So this gives me 0.038 hectometers. And recall, WebWork does like zeros in front of the decimal point, so make sure you do that when you're entering your numbers in. All right. Okay, I want you guys to try one of these with the counting. So X where you're starting. Oh, well, this is my method. O where I'm going. Count directionally and how many positions you're moving. Okay, let's see if we can do this. All right, try this one. 4.5 kiloliters to deciliters. And you can throw your answer in the chat box when you got it. DC, I don't understand. Oh, DL, your label would be DL. There you go, there you go. Yeah, perfect. 45,000 is the correct answer. K to D is going to go right 1, 2, 3, 4 places. So 1, 2, 3, 4, and you end up with 45,000 DL. Very good, very good. Okay, you guys okay with that, or do we need to do one more? Because I've got one more, but are you good? You're good. Okay, let's skip that one. Now the last one is I call it jumping across the pond. So if you're gonna watch any videos that go with this, this is the lingo that I use. And I use this as the US uses the customary unit of measurement. Europe uses the metric system. So if you jump across the pond, meaning the Atlantic Ocean, you have to go from customary to metric or vice versa. And so when we have to go from one to the other, I call it jumping across the pond. And if you look at your yellow sheet, page 245, the third group of boxes down are some conversions that jump across the pond. So you'll notice that not everything has a conversion across the pond. Like feet. If you start in feet and you need to cross the pond, it doesn't work because inches, yards, and miles go across, but feet don't. So you might have to do some converting within the customary first and then jump, or you might have to convert within metric first and then jump. It just depends on the problem. So I would call this an easy one, right? So we'll do an easy one together, and then I'll have you do an easy one on your own. So part of the deal with these is recognition, right? You need to be able to recognize that pounds is customary, kilograms is metric. So part of it is just knowing where to look on your yellow sheet to get the appropriate information, and that is half the battle. So same concept, though. I'm still going to start with what I'm given. I'm given 170 pounds. Now, I've already mentioned that I would consider this an easy problem because it's one step. If you look at your yellow sheet, you will see that pounds do go directly to kilograms. So because I want to get rid of pounds, pounds are going to go in the bottom, kilograms are going to go in the top. So let me make sure I get this right. 1 pound is 0.4536 kilograms. So same factor label method makes my pounds go away. And because my non-zero numbers are both in the numerator, I'm going to multiply. And I end up with 77.112 kilograms. So anytime I'm feeling bad about my weight, I simply just change my weight to kilograms, and all of a sudden I feel better. So it's a good skill, right? Being able to convert from pounds to kilograms is a good skill. So this, might be the only thing you have to do, one step and you're done. You might have to go from there. And depending, right, when we did metrics, we just counted left to right. So you may still have to do some counting in here. All depends on the problem. All right, I want you guys to try one. My trophy is 170 centimeters tall. How many inches is this? Let me know when you're stuck or you're good. Either one. Or feel free to throw your answer in the chat box. $66.93 is a correct answer. So for the folks at home, 170 centimeters, we can go 1 inch is 2.54 centimeters. That makes my centimeters going away. Top to bottom, we divide. And as Matt put in the chat box, 66.93 inches is the correct answer. Not too bad. All right, now let's do what I would call a horrible one, because they're not all that easy, right? And I think everybody knows that. So let's do a horrible one together. 16 ounces is how many milliliters? Well, we're talking about liquids. If you look on that middle spot on there, you'll notice that volume, the only thing that jumps is quarts and liters. Well, I don't have quarts or liters, right? So that's a little bit of a troublesome. But I'm starting with 16 ounces. Now, 16 ounces is customary. So if I want to jump across the pond, what is my goal to get to in customary? What's the only thing that goes? I don't know if that question makes sense. Quarts, exactly. So that's got to be your first goal is, hey, I need to get those ounces into quarts so that I can jump across the pond. So if I'm going to ounces, what's the first thing I'm going to change to? Because ounces don't go straight to quarts, right? I've got to start by taking ounces to cups. Yeah. So ounces on the bottom, and they go to cups, right? Let the label guide you. So I know that 8 ounces is 1 cup. Makes my ounces go away. Now I'm in cups. Well, that's great, but I don't want to be in cups. I need to be in quarts so I can jump. So if I want to get rid of cups, cups go to pints. So 1 pint is 2 cups. And that step is great because it gets rid of cups, but I'm still only in pints. Okay, so my next step, okay, pints in the bottom. Pints go to, oops, that's a Q. Pints go to quarts. So 1 quart is 2 pints. And now we're happy. Well, if you're not, you should be, because quarts allows you to jump across the pond. So I still want quarts to go away, so quarts is in the bottom, but now I can go to liters. So 1 quart is 0.9464 liters. Okay, now recall, going from liters to milliliters, we did a counting method, right? We moved our decimal point. So we need to go ahead and do the math in this green and yellow problem in order to get a number so that we can move our decimal. So what do we get when we take 16 divided by 8 divided by 2 divided by 2 times 0.9464? Good, excellent. So we end up with 0.4732 liters, right? Because that's where my label is right now, is liters. But I don't want to be in liters. So think back to our metric conversions. If I'm going from liters to milliliters, which direction am I moving my decimal and how many places? Ooh, we're not going to go left. We're going to go to the right, exactly, because you're starting with the liters, moving to the right 3 to get to milliliters. So 1, 2, 3. So my new answer is 473.2 milliliters. That right there would be the hardest type of a problem you will see in this section, because you had to convert in US metrics, then jump across the pond, then convert in metrics. It's got a little bit of everything from that one section. Okay. Questions on section 10, because that's what section 10 is. US metric by itself, metric by its, or US Customary by itself, metric by itself, and then jumping across the pond, playing back and forth. So any questions on any of those? Okay, in that case, let's go ahead and jump into section 11. Clean off this dirty screen. So section 11 is more conversions. And if what we just did makes sense, then this, well, after temperature, we're going to do more, what's the word I'm looking for? More factor label method. So with temperatures, you'll see the next boxes down, set of boxes down on your yellow sheet, you have two formulas for temperature. Now, basically these formulas are the same. One is derived from the other. So whether or not you start with one, if you do the math right, you'll get the same answer no matter which formula you use. The first one that they give is F equals 9/5 C plus 32. This is if you have Celsius, because you can see Celsius is in the beef of the problem, as I call it, and you're trying to find F. So if you're trying to find Fahrenheit, you want the F to be by itself. Similarly, in the second problem, if we have Celsius equals 5/9 times F minus 32, now we are given Fahrenheit and we're trying to find C. So if you're trying to find Celsius, then you have, you use the second one. But again, if you do your math right, you'll get the same answer either way. Okay, so we're going to start by playing with each of these formulas from your formula sheet, and we'll see how they go from there. Any questions on either of these? I'm guessing you've probably seen these formulas before. Okay, so we're going to start with changing 72 degrees Fahrenheit to Celsius. It helps if you kind of have the formula to go with. So we're given F, we're trying to find C. So I want C to be by myself because that's what I'm trying to find. So C equals 5/9 times F minus 32. Where do I start? What do I do in this problem? Any idea where we'd even begin? There you go. Yeah. So Matt there kind of did two steps in one, which I'm totally okay with. You got to take that 72 and you got to chuck it in for F. So our first step is to subtract. You got to do the order of operations. So inside parentheses is true. So we're going to take 72 minus 32 and get 40. And so essentially you're taking 5/9, that's a times symbol, 5/9 times 40 because parentheses means times. So if I take 5/9 times 40 over 1, you can type it into your calculator just like 5 divided by 9 times 40. Mathematically, that's the same. And we should get a temperature of what? 22.2. Exactly. So 22.2 degrees Celsius would be the answer on that one. Okay. It's really just key that you plug in the correct number for the correct letter. And you can see it's given Fahrenheit, and that's why we plug it in for F. So if you can manage that, the rest is following the order of operations. So that's kind of a key thing. All right, so let's go the other way. Change 4 degrees Celsius to Fahrenheit. So now we're going to, I need a pen. Now, since we want to find Fahrenheit, we're going to put F by itself and use our formula 9/5 C plus 32. Notice there are no parentheses in this problem, so you can't add them in. The problem is what it is, and so we're ready to do. So what, right, we start by taking that 4 and plugging it in. So 9/5 times 4 plus 32. Order of operation will tell you to do this multiplication and division first, add 32 at the end. So what do we get? 32.9 degrees Fahrenheit. Fantastic. All right, so temperature okay for you guys? Making sense? Know where those numbers came from. Perfect. Okay, then let's go back to more conversions. So, those temperature conversions are kind of thrown in, but they're different formulas. So it's kind of a weird little break, I guess. But now we're going to get into more of the factor label method conversions. So one thing that I want to throw out before we really kind of get started on anything is that we're going to be talking about area and volume. And if you think about area, so like if you're going to carpet your floor, so if you're going to carpet your floor, you got to talk about like, here's my floor and I want to fill in the side. So, if I'm talking about a rectangle, I've got area is length times width. And these are other useful information at the very bottom of your yellow sheet. So area is length times width. Now, if I was talking about 10 inches times 10 inches, well, multiplying the numbers is easy. 10 times 10 is 100. But inch times inch, so this would give us 100 inches squared. So if we're talking about area, we're talking about square units. And those square units are going to impact how we do the process of our conversions. Cubic units are 3-dimensional, right? Volume is like if you're going to fill up a box. So if we're filling up a box, we're going to have like length times width times height. Well, now I have 3 dimensions, right? Cubic units. So we would have like inches cubed. So these exponents are going to guide us in how many times we need to do our conversion. And that will make more sense, I think, when we get into an actual problem. So, all right, let's jump in and see how it goes. Okay, so this is actually a question straight out of WebWork. So the nice thing is if you're here, you watch the video, you're going to have one of your homework problems in your notes. So there you go. So what is the area of a sheet of paper in square feet? Well, first things off, you have to know what the dimensions of a sheet of paper are. And WebWork does assume that you know that, which I think is a little bit weird, but it is what it is. So do any of you know what the dimensions of a sheet of paper are? If not, that's fine. I will tell you because that's what I do. 8.5 by 11. Yeah, and what units are we in? Inches. Great. So 8.5 inches by 11 inches is a sheet of paper. So if we think about this first, we can find the area of a sheet of paper knowing this information, right? How do you find area? Well, you multiply length times width. So what is the area of my paper? And first, let's just start in square inches. If I multiply 8.5 times 11, what's 8.5 by 11? Where we at? If I multiply those two, 93.5 inches squared. You guys with me? So I multiplied length times width, 8.5 times 11, which gave me 93.5. And because I have inches times inches, that's why I have inches squared. So that's just, area, which is not a conversion at all. It's just math. But now we want to go from square inches to square feet. So you're going to use the same identity ratios that we just used in section 10, but now we've got to think of it this way. If I want to get rid of inches, I'm going to put them on the bottom. And my inches go to feet. So 1 foot is 12 inches. But this inches squared here in yellow is made up of inches times inches. There are 2. So because the exponent is 2, it implies that I need to do this conversion twice. Okay? Because inches times inches gives me inches squared. So inches times inches gives me inches squared. That allows my units to cancel out, similarly to what we did in section 10. And then the math is very much similar to section 10. I start with 93.5. Because both of these 12s are in the denominator, I'm going to divide by 12. Then I'm going to divide by 12 again to get the area of this sheet of paper as 0.65 square feet. And the feet are squared because there are 2 of them, right? Feet times feet is feet squared, right? Have I lost anybody? Is this all making sense? You guys still with me? Okay, good. So that's really the big difference between what we did in section 10 and what we're doing in section 11, is that now we may have to do these conversions more than once. And it's all dependent on basically the exponent of your labels, right? That's the easy shortcut way to think about it. That's the way I think about it. Okay. All right, let's do another one. Stop me if you have questions. A bag is 18 inches by 16 inches by 2 feet. What is the volume in cubic inches? So now we're going to find the volume of this bag, how much crap we could fit in it. Now, we're going to start with cubic inches. What do we have to do before we can find the volume of this bag in cubic inches? Anybody have any idea? Looking at this is a, I don't know if they do it on purpose to try to trick you, but it is kind of a tricky. Yeah, and Matt, you hit it right there on the head. We've got inches by feet. So the first step is to say, okay, if I have 2 feet, how many inches is that? So you can either do that, in your head, or you can think, okay, 2 feet. Well, 1 foot is 12 inches. So that cancels out my feet, and that leaves me with 24 inches. So you can kind of rewrite that. Instead of writing 2 feet, you're writing 24 inches. That allows us then to find our volume. Volume of a rectangular bag is length times width times height. So 18 inches times 16 inches times 24 inches. So what is the volume of this bag in cubic inches? $69.12. Excellent. Okay, so 69.12, and that's inches cubed. Okay, so that's the first part of this problem. Now the second part of this problem says, what about cubic feet? Well, if I want to go from inches to feet, well, let me ask this question. How many times do I need to do the conversion in this problem to go from inches to feet? 3, exactly. Because you have inches cubed, right? Inches times inches times inches. So we need to go 12 inches is 1 foot, and I need to do that 3 times. And that's kind of the key, just paying attention to your exponents. So inches, 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 that takes out these inches. Now remember, these 12s are all in the denominator, so all of them will be division. So 69.12 divided by 12 divided by 12 divided by 12 gives me what? 4, yes. And my label would be feet cubed. So if you think about what a cubic foot looks like, so a cubic foot is, it's like a box, but it's a foot long on each side. And so this bag that I made up could fit 4 of those in it, which is quite large, if you will. All right, so that's dealing with rectangular shapes. Now let's go to circulars. A soup can is 5 inches tall with a radius of 2 inches. What is your volume in cubic centimeters? Okay, so notice first that we're talking about a soup can, and we have inches, but the following wants it in centimeters. So first things first, I want to just talk about a soup can. right? And maybe some of the terminology with this. So a soup can is 5 inches tall. Well, I think that's pretty self-explanatory. It sits 5 inches tall. But the radius is 2. Where's the radius on a circle? Half of the length across, exactly. So the radius is from the center to the outside. So in this case, that's 2 inches. Because remember, the diameter is all the way across. So sometimes they may give you the diameter. In this case, if the radius is 2, the diameter would be 4, because the diameter is always double the radius, or the radius is half of the diameter. All right, so those are kind of the pieces. Now, the volume of a cylinder, which is at the very bottom of your yellow sheet, is pi times the radius squared times the height. Now for pi, you can either use the pi button on your calculator, or you can use 3.14. For the purpose of just writing on this screen, I'm going to use 3.14 just so we all have an idea, but you can use the pi button if you would like. So pi is approximately 3.14. The radius we know to be 2. We're going to square that, and then we're going to multiply by the height, which is 5. Depending on your calculator, you might do this in steps, or you can plug it in exactly like you see it. So for first step here is finding the volume in, I need to turn my page. Volume in cubic inches. That's our first step. Because that's what they gave us. They gave us inches. Why is that not what I got? I think your number's too high, Matt. Did you use 4? Or did you use 2? So like 2 squared is 4. So essentially we're taking 3.14 times 4 times 5. Yeah, 62.8 is closer. And that's inches cubed. Okay, so we're good. Okay, good. Good. So there's your first step, right? You got to find it in the units that you have. But the final question doesn't want it in cubic inches. It wants it in cubic centimeters. So I need to change. What conversion am I going to be using here to go from inches to centimeters? Everybody know? We're going to throw inches on the bottom. We're going to throw centimeters on the top. 1 inch is 2.54 centimeters. And we're going to do it 3 times. You guys are doing a great job, by the way, keeping up. There's just a lot. This is a lot of writing. There's a lot in these problems. You guys are doing a great job. So again, because we're dealing with cubic inches, right? Our exponent was 3. So 1, 2, 3 inches goes away with 3 inches. Multiply straight across, and we get a larger answer of approximately 1,029.63 cubic centimeters. Okay. Yeah, oh yeah, that's possible. Oh, sorry. On my paper, I did 62.83. So that's why my answer is slightly different, because I took that one out a little bit. So yeah, if you guys just did 0.8, then you're good. Yeah, perfect. And one thing I also want to say about that, I don't know if you guys use 3.14 also. I think we all did actually. But if you use the pi button, the pi button takes it out to a more accurate place, and your answer will be slightly off. WebWorks should be programmed to allow for tolerance for that purpose. So whether you use the Pi button or 3.14, as long as you're in that certain ballpark of an answer, you're going to get credit for it, because there is a slight difference. And also, again, as we just showed, depending on what you round to in your intermediate step, that may also throw off your answer. So good. Thanks for saying that, because I forgot to mention that. So that's good. Perfect, perfect. Okay, how you guys feeling so far? You feeling okay? Great. Okay. There's a lot in this section. We're going to skip that. I'm actually going to skip this water piece. There is a section in a part of section 11 that deals with, well, basically water and the weight of water and all of that fun stuff. And it's super interesting, but it's a little bit difficult. Well, not difficult. It's just long, and we only have 14 minutes left. So there is a spot on your yellow sheet that's called special conversions, and that's primarily from that one section. I would recommend watching that video. If you don't watch all of them, I would recommend watching that one. And if you're not sure which one that is, shoot me an email and I'll send you the link to that specific video, since I know which one I'm talking about in my head. But I think that's good. And I have other things that I do want to get to from this section, and I'm running out of time. So 16, I'm going to jump to that, which is rates. The process with rates is the exact same process that we've been doing. The difference is we now have labels on the top and the bottom. So if you look at this one, I ran 5.3 miles per hour. Recall back from the per capita section that per implies division. So 5.3 miles per 1 hour. Oops, forgot the H. So the purpose of this is saying, okay, well, now I have labels on the top and the bottom. I might have to change both labels. So in this case, we want to know what that is in meters per second. So my goal is meters per second. Now, it doesn't matter which one you change first or second, right? Mathematically, it doesn't matter. So I'm going to start with, since I'm leading this joint, I'm going to start with hours to seconds, because in my head, I can do that one a whole lot easier. I know that if I have hours in the denominator, as I do now, and I want to get rid of them, I'm going to move them to the top, right? Because we want top to bottom. That's where they cancel out. And I know that there are minutes in the hour. There are 60 minutes in 1 hour, right? I know that. Top of my head, I know that. That makes my hours go away. Now, unfortunately, my bottom label is now minutes, but I want it to be seconds. So I need to do another conversion where I get rid of minutes. So I can say, okay, now I'm going to put minutes on the top, because again, let the labels guide you. I want top to bottom cancel out. And I know there are 60 seconds in 1 minute. It's horrifying to think that you have to have that memorized, right? That you'd notice time is not on your formula sheet. So now at this point, after 2 orange problems, I am now in seconds. That's what I want. So I have successfully changed my bottom label. Well, now I want to go from miles in the top to meters. Well, I can't go from miles to meters. So let's think. If I want to get rid of miles, I'm going to put miles in the bottom. Meters is metric, so I need to jump across the pond. And I know that I can go from miles to kilometers. So I'm going to start there. I know that 1 mile is 1.6093 kilometers. Now, if you remember, which you may or may not, because this day has been jam-packed full of goodness, to go from kilometers to meters, we would move right 3. Well, I need something to move right 3. So let's go ahead and do our math in this portion to get a number, and then we can move our decimal. So when I multiply all these, well, multiply and divide these numbers, what do we get? What do you notice? So just to recall, that's 5.3, 60 is in the bottom, so I would divide by 60. another 60 in the bottom, so I divide by 60, and then 1.6093 is in the top, and that's why I multiply by that one. So when I do that math, that gives me 0.002369, blah, blah, blah. It goes on and on and on and on and on. And that's kilometers, kilometers, however you want to say it. Go back to our metric thought process. If I'm in kilometers, which is all the way on the left, I want to go to meters. Meters is in the middle. It's our unit. So I need to move to the right 3 places. So I take my decimal point and I go 1, 2, 3. So my final answer is 2.369 meters. Whoop, per second. Who has questions on that one? It's a little bit different than what we've been doing. I mean, it's similar, but different. You guys okay? You think you could try one of these? I've got another one. It's not quite as involved. That one's kind of a beast, a little bit. But a rate has, you know, different things. So let's try this one. I want you guys to try this one. I'm going to give you about a minute, not a whole lot of time to get started, because we do have, I've got one more big problem that I want to for sure get to after this one. Okay, so this one is slightly different. They give us 2 pieces of information, which can also sometimes be troublesome. So I drive 400 miles. There's one piece of information, and I average 65 miles per hour. So I know that that can be written as 65 miles per hour, right? That's an identity ratio. Those 2 things are the same, and I can flip that if I need to. Now, the key to some problems, and I would say this one, the question says how long. Well, how long implies time. So I know that when I'm looking at my answer, I want my label to be in time. Well, the only thing I have here that's time is hours. So when I'm talking about at the end, I want hours to be in the numerator. That means this identity ratio is going to be 1 hour over 65 miles. I can flip it. That's fine. It doesn't change the value. And that means I've used that one. Well, I don't want miles in my answer, my final answer, right? The final answer is how long. So I need to get rid of miles, which means miles go on the top so that they'll cancel out. So I'm going to have 400 miles over 1. That lets my miles cancel out. And if you notice, 400 is the number in the top, so I start with that. 65 is in the denominator, so I divide by 65. And I end up with an answer of 6.15 hours. And you might have been able to do that a different way. A lot of us drive. We have this idea of if I take how many miles I'm going and divide by my rate, my speed, that'll tell me how long. That's fine. There's nothing wrong with that. If you have a different way to do it, you rock it out, right? If it's kind of common sense to you, you go with it. There's nothing wrong with that. Absolutely nothing. Okay. All right. I want to do one more problem. In this last problem, it's kind of fitting. This last problem is going to lead us into your dosage calculation work that you're going to do, that Excel thing that I talked about at the beginning a little bit. So Steve weighs 188 pounds. His drug dosage is 25 milligrams per kilogram to be given twice a day. How much does he get in each dose? Okay. So this one is a little bit, I mean, it kind of depends on what you see. If you see it right away, it can be a little bit easier that, hey, They give Steve's weight in pounds. However, ooh, I need a marker. There we go. They give his weight in pounds, but his dosage is per kilogram. Right? When you go to the doctor, that's why they weigh you every time you go to the doctor, right? Because the medication that you receive, they prescribe it based on your weight. A 100-pound person and a 400-pound person do not get the same milligrams. It is different. So our first step really is to change that weight to kilograms so that we can figure out how much druggage this person actually needs to get. So if Steve weighs 188 pounds and we want to get out of those pounds, well, right now pounds is in the numerator. So to get rid of pounds in the numerator, we're going to put pounds in the denominator. I know from jumping across the pond that pounds go to kilograms, right? 1 pound is 0.4536 kilograms. That makes my pounds disappear. And that's great, right? That's what we wanted. We wanted to be in kilograms, but that doesn't answer the question. The question doesn't say how much does Steve weigh in kilograms. The question says how much does he get in each dose? So we need to somehow change his weight to drugs, right? We need the dosage of the drugs. Now, if you look at this piece here, oh, I'm back in green. Let me change colors just for fun. 25 milligrams per. Per is a fraction. So, oh, I need room. 25 milligrams per 1 kilogram. It's an identity ratio. And if you look, well, we want to get rid of kilograms. So kilograms are going to go on the bottom. And that means I can use this exact ratio. 25 milligrams is 1 kilogram. That makes my kilograms go away, and I'm left in milligrams. Now, this gives us the total for the day when I multiply these three numbers together. And so we find out that Steve is going to get, when I multiply 188 times 0.4536 times 25, I'm going to get a total of 2132. I'm rounding here. Milligrams. That's total for the day. But the question does not ask for total for the day, does it? Why, no, it doesn't. It asks for in each dose. So if I have the total, I'm going to ask a question here. If I have the total and I want it twice a day, how do I go from total to twice a day? What am I going to do? Divide by 2. Exactly. So I take the total, I divide by 2, and we end up with roughly 1066 milligrams per dose. And you want to make sure you're paying attention because sometimes it's twice a day, sometimes it's 3 times a day. You just got to depends on the problem. Something to pay attention to. Okay? Now, how does this tie into your dosage problem or work that you're going to do? So the worksheet that you're going to have is you're given 10 patients. They're given their weight, their gender, and how much they're dosed. So this person, they might tell you that, 1066 milligrams per dose, great, that's what they're supposed to get. But some of them are being underdosed or some are being overdosed. So you need to do the calculations and figure out who's being overdosed and who is being given the appropriate amount. And if you can see any patterns, who's being overdosed, who's being underdosed, what's going on. You don't have to use Excel if you don't want to. If you figure out how to do the formula in Excel and it's going to make your life easier, go for it, but you do not have to. You can do it all by hand if you want. I don't care. There's no requirement on how you do it, just that you do it. And then you do have to do a little write-up, a little paragraph there explaining all of your information. Okay, so that's kind of the math. Are there any questions about what we did today? Either of you, Lillian or Matt. And if you guys want to unmute yourself and kind of talk, I need about 2 more minutes to kind of discuss next week. So just to refresh, we did sections 10 and 11. So you have that dosage calculation problem that deals with that Steve problem from the very end. You've got a quiz and you got a discussion board. Don't forget your project 1 is due next week. Now, next week on Wednesday, I will be in Texas doing some presenting on Wednesday at this time, and so I will not be available for this session. I leave for Texas on Tuesday. So I have time on Monday I can do anything between 12:30 and 2:30 and anytime after 4:30 because I'm busy from 2:30 to 4:30. So we can either do it on Monday or we can do it Tuesday night, like late after I get to Texas and I get settled in. I can do it Wednesday late after my presentation session when I get back to my hotel. Thursday is a travel day and it's pretty much a cluster. And then, and I present on Thursday and then I travel. And then Friday I'll be available all day. So is there a day or a time that works better for you? Because I want to make sure, and I can do 2 sessions if one of you is available one day, one's available a different day. I just don't like to leave you hanging. So, we're doing sections, I think 12, 13, I don't know if 14 is included next week or not. I haven't looked. But I want to at least be available for an extra session because I can't be here on Wednesday. So what do either of you think? Do you have a preference? Do any of those times and days work for you? Thoughts? And by the way, anybody watching this video, if you have a preference on day and a time, you can feel free to let me know. Okay, so Matt, I'm free Monday, Tuesday, and Wednesday, but the rest of the week I work. Okay, so Monday is definitely my best. I have the most options on Monday. So Lillian, you generally come to these sessions as well. Is there any time on Monday that works for you that we could throw this session on Monday in any of those time spots? Either between 12:30 and 2:30 or anytime after 4:30. I'm planning on Monday being totally crazy because I got to get everything ready. Okay, free Monday, 1:30 or anytime after. Okay, so I can do 1:30 to 2:30 if you want, or we can do 4:30. Preference, either of you, 1:30 or 4:30. Math class has 2:30 to 5. Okay, so since Lillian doesn't care, Matt, so would you rather do it maybe at 5:30? Like when you get home from class, or do you want to do it at 1:30 before you go to class? Or is that not an option? I've told my entire life Monday is I have to get ready to leave, and that includes making sure everything is good. Okay, so 5:30 on Monday. That works. Good for me, good for Matt. Lil, good for you. Great. Okay, now, so 5:30, I better write that down. The nice thing is we'll have this on a Monday. That'll give you the rest of the week to kind of get things going. Okay, so remember at the beginning of the semester, you registered for this session, and once you did it once, it registered you for the entire semester because it was a recurring affair. Well, Monday at 5:30 is new. So I'm going to go in after this session, after we close out today, and I will have to create a new session, which takes me 13 seconds, and you're going to have to re-register. So I will be posting an announcement. There will be a couple announcements I will post today, right? The live link and all of that business. And then I will be posting the link to register for next week's session. And I will explain all of that for all of the people who were not here live in case they want to be here next Monday at 5:30. So we'll kind of go from there. And so just remember, you will have to re-register for that session so that you can get in. It'll be a different link since it's not on our recurring time. But I think other than that, we should be good. Do you guys have any other questions about anything at this point? And I think there might be a Wednesday later in the month of October that we might have to do this too. I'm going to Odessa next week, and I'm going to Houston 2 weeks after that. And I think I'm traveling on Wednesday that week, so we might have to do Monday 5:30 more often. So we'll, if that works. Okay, so I'm done. That's all I have. If you don't have any questions, you're free to go. If you do have questions, I'll stick around in the chat box. But thank you guys for being here and participating on this kind of a tough week and giving your feedback for next week's sessions. I really appreciate it. And have a good one. Do I know the hours Ivy Tech is open? Are you talking like just the building in general? Okay, so the building in general is open. It opens at 7 a.m. Monday through Friday. And I think Monday through Thursday, I think the building is open until 10. But I think on Friday, I think it closes earlier, maybe 5 or 7. I'm not entirely sure because I'm definitely never here that late. Saturdays, I'm not sure if it's open at all on Saturday. I know the testing center is not open on Saturday, but I don't know if the building is. Is that enough, or do you want me to? Because I can dig through my emails and shoot you an email later with the exact information, if that's better. Okay, let me write myself a note. I know we get an email periodically with hours of the building, so okay, hours of building to map. All right, look for that email a little bit later today. I should be able to get to that without a problem. No problem. You're welcome.